everyone, it's Caitlin here from Crystal Cove Conservancy. I just wanted to give you all a quick crash course in how we can analyze our Argentine ant abundance data to look for trends and see if we could figure out if there were more Argentine ants in one mulch plot type than the other. So first of all, let's take a look at the data we have. In our 10 different plots, there was no mulch, native mulch, and non-native mulch. In each of those plots, we have the number of Argentine ants present. So this is the number of Argentine ants counted inside those pitfall traps for each of the different mulch treatments. We also have a research question here so we can remember what we're answering. So this platform here, called Sage Modeler, is pretty cool. It allows us to do some really simple data analysis that really easily visualizes our data. To give you an example of what that will look like, I have some example data that I'll use to just show how everything works. So here is kind of a smaller subset of data than we have at the other one, but you can hit the graph button up here. And then to create a graph, all you have to do is drag and drop. So I want to compare our different mulch treatments. So this goes into the x-axis. And then the factor that I want to compare between them is the number of Argentine ants. So I'll drop that into the y-axis. Make sure it goes in place. There we go. Now each of these dots is one of these data points, and they're sorted into their different mulch treatments. So what we want to look for here is overall, are any of these higher or lower than the others? Does the non-native mulch, no mulch, or native mulch have more ant abundance in it? So there is definitely some variation here, but one thing we can do in Sage Modeler that's really nice is add a mean to our data. So I'll go ahead and hit here, select mean, and this adds an average. So it adds up all of our data points and divides it by the number of data points. And now we can get a general idea of how high or low each of our Argentine ant abundance was. So on average, there were 70.2 Argentine ants in the native mulch, 32 Argentine ants on average in no mulch, and 71.8 in non-native mulch. So based on this, these two here, native and non-native, are pretty similar. No mulch was a little lower. But another thing we want to think about is whether or not our data is accurate. Especially in nature, there's lots of things that can lead to variation. Some of these are much higher and lower than others in each of these. How do we know if our results are real? One thing we can do is add a standard deviation. And this really just helps us figure out what the variation in our data is. So it adds a line above and below our data that is one standard deviation away, and it tells us the spread of the data. So if our data is really tight to the mean, these bars are close together. These ones are kind of the tightest here. If there's a lot more variation, you see those bars are really big. When we start to see overlap in the standard deviations, like we have here, there might be too much variation for us to really know for sure if there's a real difference between these two. Could have been from random chance. Another thing to think about is if there's anything strange looking in your data. So for example here, there were 0 Argentine ants spotted in one of my plots in non-native mulch, even though it was really much higher in all of the others. So this could be considered an outlier or something that's really far away from the other data points. And the scientists, this is kind of something we need to think about. Do we think that there were no ants there just due to variation throughout the site? Or do we think there could have been some sort of error? Was there something blocking ants from getting into that plot? As you think about what might have caused it, you can decide whether or not it does belong in our data set. And if it was normal random variation, then maybe it should stay in and it's still representative of what happened in those plots. But if there was maybe some kind of error, or we think it was due to something completely unrelated to our experiment, we might want to take it out. So what I actually can do here is delete case. And you see it does make a massive difference because suddenly our data points are really close together. And now this one really does have a lot more ants than our no mulch here. So we don't want to automatically throw out outliers because variation can be pretty normal, especially in ecology. But you want to think about what might have caused it, and if that outlier is skewing our data in a way that makes it not useful. If If you think there's some other factor involved that isn't part of our experiment, that's when we might want to throw out an outlier. All right, so it will be your job to take a look at the actual data recently from winter and figure out if there was a difference in Argentine ant abundance between our plots then, and if those differences were likely to be significant. All right, good luck.